Okay, everyone, we are going to get started on stoichiometry. And I want to go ahead and tell you right now that stoichiometry can be frustrating because it's putting everything together that we've learned so far. If you remember at the very beginning of chemistry, I told you that chemistry is a lot like a staircase. And in order for you to understand how to do the next step, you have to get the first step. And the first step puts you to the second step, the second step to the third step, and it keeps on building until eventually you get to the top. Well, we're here now. We are at the top of the staircase, and we're putting everything together that we've used so far. We've learned how to write formulas using ions and prefixes. We've learned how to put those formulas into reactions and balance them. And we've learned how to do some chemistry math. We've learned how to find formula mass, molar mass. We've learned how to find percent composition, and we've learned how to convert from moles to grams to molecules. Well, we're going to take all of this, we're going to apply it to our reactions, and when we put all of this together, that's what stoichiometry is actually made of. And I'm sorry that I wrote that wrong. So in stoichiometry, there's really 6 types of problems, but there are 4 basic types that we're going to begin with in this little video series. And so this is series 1, or video 1 in the series. And today what we're going to do is we're going to learn how to do mole-to-mole problems. So this is going to be video number 1. Video number 2 will be these together. Moles to grams and grams to moles. And then we will cover this last one in video number 3. And then there will be some other videos that will cover some other concepts or types of stoichiometry problems as well. But these are the 4 types of problems. When we talk about stoichiometry, these 4 types are used for conversions. And we've already done conversions before, and so this is basically the same thing, except now instead of just dealing with one formula, we're going to be dealing with multiple formulas within a reaction, okay? So let's get started with the very first problem type. And the first problem type is mole-to-mole problems. Now, I'm going to move on along in these videos, but that does not mean that you can't pause and go back and rewind. And after you've watched the video, if you're still struggling on something, make a note of it, and then you can go in and comment on the video in the Google Classroom, and I will be happy to answer any of your questions, okay? So let's talk a little bit about the problem type number 1. Let me see if I can adjust this lamp. There we go. Problem type number 1 is a mole-to-mole problem, okay? So mole to mole. So basically, we're going to convert from 1 mole of one substance to a mole of another. Now, we've converted from grams to moles, moles to grams, but we've never converted from moles of one substance to a mole of another substance. And you're probably thinking, well, how in the world are we going to do that anyway? Well, to do that, we're going to have to use a reaction, okay? So we're going to use this reaction of aluminum oxide. We're going to decompose aluminum oxide. So I have 2Al2O3, and it's going to decompose into 4 aluminum and 3O2. Okay, so this is the reaction that we're going to use. Well, before we can start working a problem, we have to learn about something called a conversion factor that's very specific to this type of problem. And that conversion factor is called the molar ratio. So basically, the molar ratio is going to be our conversion factor that allows us to compare one substance to another substance. So we've never had to use a molar ratio because we've always just dealt with one substance when we were doing conversions. But now we're going to compare two different substances or three different substances to one another. And so to do that, we have to bridge the gap with what's called the molar ratio. Now, these coefficients that we learned how to put into reactions and balance last unit, these are telling us how many moles of each substance we have. So in this case, we have 2 moles of aluminum oxide. We have 4 moles of aluminum, and we have 3 moles of O2, oxygen. And we can use these numbers to create a mole ratio. So if I wanted to know what is the mole ratio of aluminum oxide to aluminum, there are 2 moles of aluminum oxide to 4 moles of aluminum. And this is a conversion factor. And I can use it just like any other conversion factor. I can use it this way, or I can flip it and have 4 moles of aluminum over 2 moles of aluminum oxide. I have a conversion factor of 2 aluminum oxide to 3 oxygen. 2 moles of aluminum oxide and 3 moles of O2. And once again, I can flip this. I can put the 3 moles of O2 on top, the 2 moles of Al2O3 on the bottom. And then there's one other conversion factor. I can compare my two products in this case. 4 moles of aluminum and 3 moles of O2. So these are my conversion factors. I'm going to use these conversion factors as I need to in order to compare the moles of one substance to the moles of another substance. And I can manipulate these to work in my problem however I see fit. Okay, so just like when we did before that there were 100 centimeters in 1 meter, and you flipped it with the 100 on top or the 100 on bottom, you can do the same thing with a mole ratio. Okay, so we're going to go on and start working a problem, because I think the best way to do this is just to launch into a problem, and then we're going to work 2 problems together, and then after we work those 2 problems, you can go on and do the assignments in the plan that's been left for you in the Google Classroom. So let's just say that in a spacecraft, the carbon dioxide that is exhaled by astronauts can be removed by its reaction with lithium hydroxide according to the following chemical reaction. So here's our chemical reaction: CO2 that's being put out by the astronauts, and it's going to combine with lithium hydroxide, which are in these scrubbers that are in the air vents in a spacecraft. And when you do that, the lithium hydroxide reacts with the carbon dioxide to create lithium carbonate, and then the byproduct of water. So this is my chemical reaction. Now, before we can do anything with a problem, before we even look at the problem itself, we have to make sure that the chemical reaction is balanced, okay? So you need to go through and we need to double check that we have the right number of coefficients. And so in order for me to balance this one, I'm going to have to put a 2 in front of this lithium hydroxide. Okay, so now I have a balanced reaction. So now I can go on to my problem. So the problem asks us, how many moles of LiOH are required to react with 20 moles of CO2, the average amount exhaled by a person each day? So this is a pretty legitimate question. If you're fixing to get on a spacecraft and travels somewhere into outer space, and you know that carbon dioxide can be fatal if it's not fixed. So this is important because I need to know how much lithium hydroxide I need to have on board in order to handle the carbon dioxide I'm going to put out each day. So if I'm going to be up there for, 10 days, that means I'm going to make at least 200 moles of carbon dioxide, and I need to know how many moles of lithium hydroxide I need to put on board in order for me to be able to survive. Okay. So the very first thing that I do, and I still do this, so if I do it, you know how we talk about in class, if I do it, then you need to do it as well. So they tell me that I have 20 moles of CO2. So what I'm going to do is I'm going to come right here above CO2 and I'm going to write 20 moles. This is going to be my given, okay? This is my given that I'm going to start with. And then they're asking me to find out how many moles of lithium hydroxide are required. Okay, so this is going to be my unknown. Okay, that's what I'm looking for, that's what I'm aiming for. So they want to know how many moles. They gave me moles, so that means I have a mole to mole problem. So what I'm going to do is, just like we've done in every other problem in class, we're going to start with our given, 20 moles of CO2. And I need to bridge the gap of CO2 to lithium hydroxide. And the way that I compare two compounds within a reaction is I use my mole to mole ratio. So I have an understood 1 mole of CO2 and 2 moles of lithium hydroxide. So my mole to mole ratio is 1 mole of CO2 to 2 moles of lithium hydroxide. This is my mole ratio. I need to put this mole ratio into this problem to cancel out moles of carbon dioxide. So to do that, I'm going to put 1 mole of CO2 on bottom, and I'm going to put 2 moles of lithium hydroxide on top. So now my moles of CO2 can cancel out, and then I just run it through my calculator. 20 times 2 equals 40 divided by 1, 40 moles of lithium hydroxide. You must check your sig figs. So my given had 1, my answer has 1, so sig figs are good, and you have to have your units. Moles of lithium hydroxide, moles of lithium hydroxide. So this would be my answer. Easy peasy. Okay, so let's do another one. So in photosynthesis, plants use energy from the sun to produce glucose, C6H12O6, and oxygen from the reaction of carbon dioxide and water. So let's go back to way back into biology, and we know that CO2 added to H2O in the presence of light gives us glucose, C6H12O6, and releases oxygen as a byproduct, luckily. So step 1, before I even look at the problem portion, I have to have a balanced reaction. So take a second and balance this. Pause it if you want to do it on your own. So to balance it, we would have 6, 6, and 6 right here in front of oxygen. So now we have a balanced reaction. So our problem is asking us, how many moles, of glucose are made when 12 moles of CO2 react with water in excess. Okay, so how many moles of glucose are made when 12 moles of CO2 react with H2O in excess? Okay, now immediately some of y'all are freaking out going, what in the world does this in excess mean? Later on, we're going to do a stoichiometry problem where this comes into play. For right now, just ignore it, okay? So we're going to go with our given. They tell us that we have 12 moles of CO2. So I'm going to come up here and put 12 moles of CO2. That's my given. And then they want to know how many moles of glucose. So there is my unknown. Okay. So we always start with our given, 12 moles CO2. And then to bridge the gap between this reactant and this product, I have to use my mole ratio. And I know that there are 6 moles of CO2 for every 1 mole of glucose. So I need to put this into my problem, but I need to get rid of CO2. So to do that, 6 moles of CO2 must go on bottom. And then that makes the 1 mole of glucose go to the top. So now I can cancel this out. And I'm going to run it through my calculator. I'm going to say 12 times 1, which of course is 12, divided by 6. And I'm going to get 2 moles of C6H12O6. Now, before I finish, I look at my answer and I have 1 sig fig, but my given had 2 sig figs. So in order for this to meet those specifications, I have to say 2.0 moles of C6H12O6. And this would be my answer. Okay, so once you've looked at this problem, I'm going to let you know when you go to the Google Classroom, let me show you real quick. When you go to the Google Classroom for chemistry, you'll look right here in classwork. Under the Unit 6, you're going to see mole-to-mole problems. And I have given you a practice worksheet that you can use. And that practice worksheet is going to give you some extra practice problems. And I have provided you with the answers. So that way you can see what you're doing. You may only need to work 2 or 3 of them because these will not be a grade. But there is a graded assignment, the worksheet 1 on mole to mole. You need to complete that and submit it in the Google Classroom. You can type your answers into the Google Doc and then upload your pictures to show me your work. If you have any questions about this, please feel free to drop your comments in the unit assignment under mole-to-mole problems where this video is located, and I can be sure to answer them. Okay? Good luck, and let me know if you have any questions.